So in this video, I'm going to be assembling this, a PiPico terminal module. It's a kit I bought a couple of years ago. I've not got around to assembling up until now. The kit comes with this, a Pico, still in the plastic wrapper, a VGA connector, a 90-degree dual row header pins, a load of resistors, a diode, a capacitor, 4 buttons, and a couple of other odds and sods. So the first thing I need to do is fit this, trim this header so that it fits onto the PCB. If you're familiar with the RC2014, you'll be aware that there's the main row of pins for standard boards, which are I think it's 39 in total used out of the 40. And pardon me, there's a second row, 20 pins for extended modules. This is an extended module, so hence the dual row. So the first thing I'll need to do is remove 20 of the 40 pins from the second extended row so it'll fit onto the back plane. So I'm going to do that now. The suggested way is to fit the connector in backwards in the board, which I'm going to do now. That way it'll just hold it in place so you can pull out the top row of pins. So let's get cracking with that now. 1, 2, 3. It's a bit tedious, this. There's always the worry that you're going to remove too many pins or remove them from the wrong side because it's asymmetrical. Right. Let's double check that. Yeah, that's looking okay. And just make sure how many more I've got to remove. Count them. 2, 3, 4. Yeah, okay. Right. A few more to remove. Yep. Let's put them how many from the top. My eyesight's not as good as it used to be. Okay, I've got it now. Just remove the rest for the bottom here. Let's just check that. Oh yeah, it's complicated by the fact that, like I said earlier, the boards only use 39 of the 40 pins of the main row. So I will need to chop the end one off to make it fit. Yeah, I think that's it. It's been a while since I've done this, just bear with me. Yeah, that's fitting fine. Right, good. There we go. So that's the end one I need to chop off now. Get my side cutters out. There we go. It's a little bit fiddly this because it's dual row. It's not like trimmed a single one. Let's just get that in there. Try that again. There we go. Perfect. Right, should I solder that on first? Or might be easier. Might be easier soldering the Pico on first, actually. Yeah. Yeah, I think I'll solder the Pico in first. Just makes it easier to get to that bottom row castellations on the Pico. Yeah, let's do that. Right, so next, get the Pico out of the wrapper. Get that on place. Yeah. And it's suggested in the build tips to just use some pins to tack it into place. So let's just see whether that works for me. I've done this in the past. I've used Molex pins. Well, I've got some pins here that I've just trimmed from the Molex header there. So I'll try and get that in. Come on. Fiddly this. There we go. That's the first one in. Get another one. Dear me. Looks so much easier in the instructions. Yeah, it's a bit wobbly. I might do it. Let's go another one in maybe. Yeah, okay. I might use blue tack here, to be honest. It's just feeling a bit wobbly. Yeah, I'll blue tack it in place. Blue tack's great. It's like second hand, isn't it? So, yeah. Just a couple of blobs of blue tack should do the trick. That's better. Okay. Yep. I'm happy with that. That's nice and lined up. It's in the soldering iron. Okay, it's getting pushed up by the pins now. Let's just get rid of these pins. Just use blue tack and line it up by eye. Let's put that down a second. That's better. Yeah, I'll just do it by eye. It doesn't have to be perfect. The castellations are kind of... Yeah, it's just an aesthetic thing, really. As long as it's near enough, the solder will flow and it'll make a connection. Right, I'm just going to move those over there. Soldering iron's at the right temperature. Right, let's get soldering. Let's just do the top right first. There we go. Perfect. Just double check that. Do the bottom left now. There we go. Perfect. Right, just reflow that a little bit. Just double check that's all nice and level. Remove the blue tack. Just that over there. Right, I'll get soldering the rest now. I'll probably skip through this because it's going to be a bit tedious. But you just basically solder it like you solder anything else. Probably just hold it to the top of the castellation, the solder, and heat it where the notch is, and it'll just flow in place. You don't need an awful lot of solder. There we go. There we go. That's coming on quite. That's nice and yeah. It's going on well. Right, I'll skip forward this. I'll see you at the end. Just double check that. Yeah, that's looking fine. Pretty good actually. Yeah. Yep, that's fine. Happy with that. Let's just do these 3 pins at the top. Yeah, so it's pretty straightforward. Soldering it directly to the board. I think you have to do it this way because there's not enough room to have it stood off with header pins. Right, now I can fit the header. More soldering, joy. Right, let's just get this. Yeah, go on, and you get it's a bit fiddly. This can't see the pins. There we go. So just gonna tack it in. Top, no, left and right. Just tack it in place, and then I can adjust it to make sure it's flush at 90 degrees. Otherwise the card will be lopsided on the back plane. Right, let's just tack it in place then. Right. There you go. One. And the other side. Oh, hang on. Try again. There we go. Yeah, you want this really to be flush, so just tack it in place. Let's just check it. It's a bit lopsided. So what I'm going to do is I'm just going to hold it in place on the other side of the board so it's absolutely flush at 90 degrees. And just, there we go. Force it a little bit whilst the solder's hot to make sure it's, yeah, that's perfect. It's flush 90 degrees. Look at that. Yeah, bob on that. Happy with that. Right, so I've got more soldering to do now. So that's 39, 59, 57 more to go. Right, so here we go. I'm probably going to speed through this again. Right. So you may have noticed that my board's got a few more components on from where I left off. That's because the video broke when I was recording. I've got I've got buttons, capacitor, VGA connector, the header pins for the jumpers, and a diode. So just notably, the capacitor, you've got to make sure the priority is right on the capacitor. So the white stripe goes on the left hand side as you're looking at the top of the board. where the PCB shaded in white. There is a tiny plus on the right hand side of the circle where the capacitor goes. Just about see it. I missed it at first. Obviously it's a polarized component, as is the diode. That's got a white stripe on the right hand side, and the PCB's marked with a white stripe. Just make sure that they're aligned correctly, otherwise things may not work correctly. Yeah, that's looking pretty good. I am happy with that. Right, I've got a bit more soldering to do now. I've got a load of resistors left to solder on. Yeah. Now this is a little bit more complicated because you can see they're all going on the top row here. I've got to make sure that I put the right resistors in place they're used for resistor ladders. I've cheated a little bit. I've marked on the strips that hold the resistors in place the resistor values just to help me, so I don't have to keep referring back to them. And you can measure this quite simply by using a multimeter. Just set it to the correct range, ohms, and just probe the resistors on either side of the resistor on the leads. You can measure the ohms value of the resistors using the multimeter. So that's, I've got this one here. Just move that way so you can see it in the camera. So yeah, it doesn't matter which way the probes go, positive or negative, just get it in place. A bit fiddly because the leads are a bit thin, so let's just get that in place. Measure that. Oh, stay still. And that, and you can see this is 8.07. 8.07, I think it should be 8.02. So yeah, that's good. So you can measure all of the resistors, mark on them where necessary, and you can see on the PCB that all the resistor values are marked. So it should just simply be a case of fitting them into the right place now. Out of the way. Alright, let's go for it. I'm probably going to speed through this again as well because it's going to be a bit tedious. It should be fairly straightforward. Let's pull that off there. And yeah, I've got this plastic former which is quite good. I got it off eBay for pence. And what you do is you just measure, make sure I get the right width. It's got kind of different widths there. Put the resistor in there, bend the leads round the former, and you get a nice, let's double check that, nice bend in the leads. It's just a labour saving. You don't need to do this, you can do it manually, but I find that you get much better results by doing it this. There you go, look at that, perfect 90-degree bends on the resistors. You just got to make sure that, yeah, come on, get in you go. Just got to make sure, look at that, perfect, right. Just got to make sure that you pick the right width really on the former. So I'm going to go through and form all of these now. I'm going to stick them all in place first, and then I'm going to solder them all up in one go. So yeah, I'll see you at the other side. Oh, it doesn't. These aren't polarized as well, by the way. Of course, resistors are not polarized, so it doesn't matter whether or not you put them in the upside down, because there is no upside down. So I'll stick all of them in by value, and at the end I should have no resistors left, and everything should fit in the right place. I won't have any left, I won't have any that don't fit in the hole. Right, I'll see you at the other end then. I'm going to forward line through this. It's a little bit tedious. Probably the most difficult part of the job, to be honest, because you've got to think about this. soldered all of the resistors on here now. I've done quite a good job actually, even if I say so myself. I've trimmed the back and I've given it a quick wash with IPA in order to get rid of all the flux. So that's it, it's built. It's quite a nice board actually. The last thing to do is update the firmware on this. Now I've no idea what firmware is on this Pico. I suspect it's got some on here already. I'm going to update it anyway because I've not touched this in 2 years, so what I've probably got in here is probably out of date. So I've got this USB cable connected to the PC already. Plug it into the Pico. It will provide power to the Pico. The LED's flashing, so that's indicating some things on here. Looking at the documentation, I suspect it is the firmware, because it will flash the LED if no keyboard's fitted. So I'm going to put it into program mode and update the firmware. So I'm going to keep hold of this button here, and then I'm going to press and depress the reset button, then let go of the button on the Pico, and now that should appear as a removable drive in your operating system of choice. So you take the UF2 file, the picoterm.uf2 file from the Git, I'll put the link in the description, and you simply drag it over to the removable drive that's appeared, and that's it, it's programmed. There are 2 versions of the firmware available. There's 40 column and 80 column. I have it on reliable authority that the 80 column version is better, even though it's in monochrome. You can only install one at a time. Oh, there we go, it's flashing again, so that means that the firmware's taken. Right, so last but not least, test it in the RC24 itself. Job is a good one. I've now fitted the module into my RC2014 backplane. I've got a RC2014 Pro, yours might be different. You see the modules fitted here into an extended connector on the bus with the 40 pin and the 20 pin headers there. That's looking pretty good. So the next thing is to connect everything up and try it. I've got a VGA cable here. I also need a OTG Connect kit. I think I picked this up off Amazon or something for about £5, if that. And a keyboard. Well, I'm going to use a wireless keyboard, which I normally use for my Linux box. So that's the receiver for the wireless mouse and keyboard. Let's get all this connected up. So first, the VGA connector. So that goes in there like that. I'm going to spin the board round now. There we go. Get the OTG Connect cable out. That goes in. Make sure I get it the right way around. Curse of USB. Got it the wrong way around first time. And the second time. Oh, come on. There you go, it's a bit stiff, that's all. So that now gives me a USB connection for plugging a keyboard in. It could be a standard USB keyboard. I'm just going to plug my wireless transceiver in there like that. I think this will work. I use it for my Mr. FPGA with no issues with this setup. Well, we'll find out, won't we? So just need to power it now and see what it looks like on screen. Right, so got my keyboard. We'll be looking at this monitor here. Flick the RC2014 on and let's see what the crack is. Oh, there we go, brilliant. So it's booted straight into the small computer monitor, the Grant Searle one, the RC2014 boots into, or at least mine does. You've also got this nice Picoterm splash screen now, which you don't normally get when you're running it from a terminal on the PC. Right, let's see if I remember how to do this. So I'm going to CPM, keyboard's working fine, got it on UK layout. There we go, straight into CPM. I've got BBC Basic on drive D. That's all working. Good, good, good. Job, as they say, is a good one. So let's see what else this can do while we're at it. On the boot screen, there was some kind of command sequence I'm going to. Help, Control Shift H. Let's try that. Control Shift H. So I can go into a configuration menu. Try that again. Shift plus Control plus M is the configuration menu. Oh, there we go. I have to exit help before you do that. So, ooh, got different terminal colours. Let's try 1, 2, 3. I like it on amber. Let's keep it on amber then. Got different character set as well. I'm not going to touch the baud rate settings. It seems to be working okay as it is. Uppercase S to save. Let's have it in light amber. Uppercase S to save. Reboot. There we go. So I'm going to boot in amber mode. That takes me back to using a PC, back at Software Creations. What else can I do here? It's command line interface. I'm not going to fiddle around with all this. Anyway, that all seems to work. The jumper settings on mine are set to the UART1, so both are in the top position, and that just seems to work fine with a standard RC2418 Pro configuration, because I'd normally be going through UART1 on the serial interface here. That's disconnected now. I won't need that unless I'm copying stuff over to the compact flash drive. Right, I'm going to start playing around with this now. It was a little bit more soldering than I was expecting, but that's a satisfying result. It means my RC2014 now is no longer dependent upon a PC or laptop. It will just work as a standalone computer now. Yeah, cool. I hope you enjoyed that build. A little bit truncated in places because my video recording system broke. Should give you an idea how to build one. I'll see you in the next video. Cheers.